everybody. So we are wrapping up the year, and this is going to be the last section of notes, not the last video necessarily. And where you should be is on page 45 in your packet. So again, that's page 45. And so now that we've been introduced to all the different ways to solve, let's get that a little more focused. There we go. Now that we've been introduced to all the ways to solve, we're going to have to figure out which method to use when given a certain problem. So what I'm going to suggest you do is I've got a piece of paper and I have it landscape so it's longer rather than taller. And we're going to make a little map. And this map is what would normally be going at the top of page 45, but it's something you can use when you take this showcase of learning. So here we go. So I'm just at the very top, and in the center, we're going to talk about how do you solve a quadratic. And then remember, these are all going to be quadratic because the highest exponent or degree that we're going to see is going to be a 2. So the way you're going to approach these problems is when you look at the problem is how many types of x do you see? So we'll make the map and then we'll explain as we go through problems. So if you see one type of x, you're going to follow a route. But if you see more than one type of x, so more than one type, okay, then that'll be a different route. So let's talk about if there's more than one type, because this is what you're going to be most familiar with. So depending on what it is, the first thing you're going to want to make sure is that it is in standard form. That's what SF is going to mean, and that it does equal 0. All right. From there, you're going to see if it's factorable. And then just a reminder, if it's factorable, you want to first look for a GCF. Doesn't mean it will happen, but it might happen. And then if there's 2 terms, you will use that difference of squares. If it happens, doesn't mean that it will. And then if there's not 2 terms, then we're looking for 3 terms. And for there, you make your x. Now, not everything, as you've seen, has been factorable when it was in standard form equaling 0. So your other option is if it's not factorable, like that. Whoops, you can't see that. If it's not factorable, then what we're going to use is the quadratic, I'm going to abbreviate, formula. And so it's still pretty new for us. So we're going to write down what it is. And again, it's based off of ax squared plus bx plus c equaling 0. So you will have to establish what a, b, and c are. And it goes x equals opposite b plus or minus. Then you're going to make a square root. And then in that square root is b squared minus 4 times a times c. And then all of this is divided by 2 times a. All right? All right, so let me back up over here. Once you do get it factored, either way, what method you're going to use from there is the 0. Sorry, not enough room on my desk. 0 product property. Okay? So again, if it starts out that there's more than one type of x, if it's factorable, you go one route, and if it's not factorable, you go another route. Now, if there is just one type of x, what we're really going to have to look is to see what form it's in. So if it's already in factored form, then this is as easy as it gets. You're just going to go to the 0 product property. Now, if it's not in factored form, then technically the form that it's in is vertex form. That's what it's called. But you'll notice it because there's just one type of x. and you are going to use what's known as the square root method, which is essentially you working through the order of operations backwards. So you will move any addition, subtraction first, then you'll move multiplication, division, then you'll undo exponents with your square root. And it's here, remember, that you're going to get your two answers of a positive and negative. And then from there, if there are parentheses, then you deal with the things that are in parentheses. And that is our little map. So let's take a look now on this page, okay, and how you would do some of these problems. So first thing I'm going to look at is just maybe go through and look at, is there one type of x or more than one type of x? So if it's one type of x, I'm going to circle those problems. And if there's more than one type of x, I'll put like a square around the problem number. So this has one type of x, but this has more than one type of x because it has an x squared and an x. So this is one way to solve it. This is one branch, and this is a different branch. So now I'm just going to go through and help you recognize that. So here's more than one type of x. I've got an x squared and an x, so put a square around it. This just has one type of x. I only see an x in there, so I'm going to circle it. This problem has more than one type of x, so I'm going to put a box around it. And then this problem also has more than one type of x, so I'm going to put a box around it. So let's approach maybe all of our circled problems first. So first of all, is this in factored form? It's not. It's actually in vertex form. You're just missing the parentheses of the vertex form. But either way, what I can then do is the square root method. And so I'm going to draw my wall, and I'm just going to work backwards in my order of operations. So let me get my wall drawn. And now my goal, looking at this, is to move any addition, subtraction first. So this is 3 times x squared minus 48. So that minus 48, I'm going to undo that by adding 48. Cross this off here, add it here. So now I have 3x squared equals 48, or 3 times x squared equals 48. So that times means there was multiplication, so I'm going to move the 3 through division. So I'm going to divide by 3, cancels out, divide by 3, and then I get 16. And now to undo the exponent, I will take a square root. This is why it's called the square root method, because no matter what, I'll always have to do this step. And this is where I will get 2 answers. So if I'm using my calculator, the square root of 16, the calculator will tell me 4. But I also have to remember that there is a negative 4 in there. And so for this one, I'm just going to write them out as 2 very separate answers. So let's take a look at a square problem. So with more than one type of x, meaning x squared and x, first I need to make sure it's in standard form and it equals 0. So it's not in standard form, so I'm going to move this 3x over by subtracting it. And when I do that, that makes this side equal 0 now. And then when I subtract 3x over on this side, here's that wall. None of these are alike, so I can't combine them, but I'll put it in standard form. So x squared, then the x term, and then the constant at the end. So what I'm going to check for first is factoring, because if I can factor it, that's much faster than the quadratic formula. So let me just put my x, over here. I've got some room. So factors of -5 that get me to -3. Well, there aren't any, so this is not factorable. So instead, what I'm going to do is the quadratic formula. So I'm going to identify a, which is this invisible 1, b is -3, and c is -5. And now, with my quadratic formula, because it is not factorable, I've got it here, and it's going to go, fold my paper in half here. It's going to go, let's see, x equals, and I'm going to take the opposite of b, so I'm going to write 3 instead, plus or minus square root, and then I'm going to take b and square it, and I do that in my head. -3 times -3 is 9, minus 4 times a times c, and then all of this is over 2 times a, so 2 times 1. So from there, if you remember, we're going to focus inside the square root, and we have to do the multiplying before we do the subtraction. So when I multiply 4 and 1 and -5, I get a -20. And when you subtract a negative, remember those subtractions and negatives come together and make a positive. So we're really going to be adding a positive number here. So since I don't have a lot of room, I will still have 3 plus or minus, and now it's 9 technically adding to 20, so that's 29 in here, and over 2. So this is where we talked about the good answer, the better answer, the best answer. I do want you to think about 29, and 29 is not perfect, but maybe it has factors that are, and so if it does, we'll deal with that, but if it doesn't, then we're done. And so the only factors of 29 are 1 and 29, and so we have our 2 answers. One answer is 3 plus the square root of 29, which is about 5. So 3 plus about 5-ish, so around 8-ish, and then 8 divided by 2, our answer is around 4. The other answer is 3 take away the square root of 29, so again 3 take away about 5, so this is around negative 2-ish, and then negative 2-ish divided by 2 is around negative 1-ish. So we do have 2 answers, you just might not notice them right now. All right, let's go to number 4. So number 4 we circled because again there was one type of x. So with one type of x, it's not in factored form. I will want to use my square root method and move addition, subtraction, then multiplying, dividing, then exponents and parentheses. So here it's x plus 3 squared minus 16. This is the only addition, subtraction I'm going to move because the 3 is in parentheses. So I'm going to add 16. I'm going to cheat and just put that there would be 16 over here. There is no multiplication division. This is x plus 3 squared. I never said timesing or dividing. So I'll skip this step, and now to get rid of the exponent, I'm going to square root and get my 2 answers immediately in this step. So I'm going to square root this side, and that cancels out the squared, so I just have x plus 3. And then I'm going to square root 16, which the calculator will tell me 4. But I also have to realize that there is a negative 4, and from there, I'll deal with the stuff in the parentheses. I will have 2 problems. One of them is x plus 3 with the positive 4, and the other one is x plus 3 with the negative 4. In either situation, when to move the 3, I'll subtract 3. So when I subtract 3 from 4, I get 1. But when I subtract 3 from the negative 4, I actually get negative 7. So here are my 2 answers. So let's go to number 3. Number 3 was also boxed because there's more than one type of x. So I do got to make sure it's in standard form, which it's not. It's not equaling 0. So I'm going to move this 4 over by subtracting. So when I subtract 4 here, I get the 0. And when I subtract 4 on this side, because these are not like terms, I'll just write it in standard form. So I'll start with my 2x squared, then my 7x, and the minus 4. So your goal is to try to factor, because again, that's a lot faster than the quadratic formula. So what are factors of negative 8 that get me to 7? And that would be a 1 and 8 with the 1 being negative. And now I'll make my parentheses and drop those x's in. Leave a little room in case I need a number, and I will, because x times x doesn't make 2x squared. I will have to put a 2 with one of these. And now x can make either of these, so I won't worry about that one, but 2 can only make 8. So 2 times what makes 8? Well, that's a positive 4. And then x times what makes negative 1x? That would be a negative 1. And now that we have factored, because, sorry, I did not check to see if there was a GCF. There wasn't. I just went to my 3 terms. I'll do that zero product property. So what makes this factor equal 0? And what makes this factor equal 0? And so this is our simpler one. It's negative 4. And in this one, I'd add 1 over, and then I would divide by 2. So my second answer is 1/2. All right, let's take a look at 5. So 5 and 6 are also boxed because there's one type of x. This one's good. This is in standard form and it equals 0. So the first thing I'm going to do, since there's more than one type of x, and it's already in standard form equaling 0, we are going to see if it's factorable. So here goes my x. I should check, sorry, is there a GCF? And there's not. So I just need factors of negative 5 that get me to negative 4. And so far it looks like it's working, and it will work once I make that 5 negative. So it's factorable. I'm going to make my parentheses, drop in my x's, and x is enough. That makes x squared. And now since these are both x, let's have this x make 1x by plus 1, and this x can make negative 5x with a negative 5. And again, now that it's in factored form, we can do our zero product property. And if you don't see your answer, set that factor equal to 0, set that factor equal to 0. Here I would add 5 over, and here I would subtract 1 when I get my two answers. The next one is almost in standard form. It's just not equaling 1. So I'm going to move the 1 over by subtracting, and this time I can combine it with that negative 4. So when I write standard form, I'll have 3x squared minus 5x, and then negative 4 take away 1 is another negative 5. So now first I'll check to see if it's factorable according to my math. So are there factors of negative 15 that get me to negative 5? And 1 and 15 won't work, 3 and 5 won't work, so this, as it turns out, is not factorable. So now I'm going to go to my quadratic formula, and I'm going to establish my a, b, and c. A is 3, b is negative 5, and c is negative 5. And now I'm going to make my quadratic formula. So it goes x equals opposite of b, so I'll put a 5 plus or minus square root, and then in the square root I will take b and square it, so negative 5 squared is 25, it's always a positive number, minus 4 times my a times my c, and then all of this will be over 2 times a, so 2 times 3, which is 6. So from there, go straight to your radical, go straight to your multiplying. If this is difficult, you don't have to multiply left to right. I would do 4 times negative 5 for negative 20, and negative 20 times 3 for negative 60. And again, when you subtract that negative, it becomes plus 60. So 25 plus 60 will give me 85 in here. And then that's a good answer, but let's see if we can make it better. Is there any part of 85 that's perfect? And it's not, so this is good as the answer is going to get. Again, there are two answers. The square root of 85 isn't too far off from the square root of 81, which is 9. So this is about 9. So 5 plus 9-ish, that's like 14. And whatever 14 divided by 6 is, that's one answer. And then 5 minus 9, that's like a negative 4-ish. And negative 4 divided by 6 would be my other answer. But there are two answers here. All right, so that's page 45. Let's talk about what you're going to practice now and just make this kind of one video, because this is definitely our more challenging subject or topic for the whole thing. So let's go through again and let's circle the problems that have one type of x and box the problems that have more than one type of x. So box is more than one type, and a circle will mean one type. So more than one type, because it's x squared and x, I'm going to box. I just see x squared, so that's one type. I'll circle. Here, even though there's two of them, they are the same type, so I will circle. More than one type, so I box. More than one type, box. More than one type, box. Flipping the page. One type, circle. More than one type, box. More than one type, box. More than one type, box. Number 11, just one type, so I circle. And more than one type, box. So remember the boxes, make sure they're in standard form and equaling 0. So a problem that we boxed that was not in standard form, these are all equaling 0 on page 47, sorry. Page 46, though, that I boxed, this one's not in standard form. So I'd have to move the 5 over by subtracting, and that'll make it x squared minus 2x minus 5. So let's go ahead and get this problem going. First, I do want to see if it's factorable, because that will be faster. So are there factors of negative 5 that get me to negative 2? And the answer is no. This is not factorable. So in the end, we will be using the quadratic formula. Let's look at the problem next to it. So there's more than one type. So there's not a GCF. I should have checked that here. So are there factors of 4 that get me to -5? Well, I can do 1 and 4, and if I make them both negative, that'll get me +4 on top and -5 on the bottom. So this is factorable. So you can start, drop your x's in, realize that x's won't be enough for 2x squared. You'll have to make the 2. And then I'll let you finish this to get the side numbers. Okay? So that is how you get this going. When you're done, be sure you check your answers. All right? And I will be putting next to it, QF will mean quadratic formula, and F will have meant that it was factorable. And when it's circled, it just depends. Is it in factored form? I didn't notice any of them, so I'll be putting a square root for the square root method. Okay, that's it.